Yes, welcome back. So in the previous video, we have discussed about the data processing, right? Nothing but the data cleaning. There we involve with selecting the few columns, okay, renaming them and converting the values in that column into the uppercase, okay, and also counting the null values. Typecasting has also involved, and also the we use the regular expression concept to replace some of the unwanted values, okay. Those and all involved, right? And also we have seen yesterday while dropping the two columns, okay, prescribed ID and the drug name, you observed the remaining null values also got dropped, right? This was the case, right? So previously it was the null value is 22 in the prescribed ID and the drug name contains 15. Okay. So when you apply the condition like drop NA and given the column name, the automatically the sum of the null values presented in a column, like let's say prescribed city, state, and specialist got also dropped. That is all because the purpose why I did not explain there, and also some people mentioned in the comment section. Okay, the reason behind is right. Uh, the way the data frame has been structured is different. We cannot say exactly it will work for all the data frame if there is any relation between them columns. Let us say you have the three columns A, B, and C, and A and when you drop the null values in the A and C, sometimes indirectly it will affect the null. It is also drop the null values presented in a column B. Okay, that is there may be sometimes a relation between the columns that will affect indirectly dropping the null values present in a column. It won't happen all the time, and we cannot say it will happen every time. Okay, so that was the condition. And also you can observe the txc count has when you before dropping the condition it was 3, after dropping it was 2. So today we are going to discuss these two values has to fill with the average of the txc underscore count. Okay, and also we are going to discuss about the transformations according to the client use cases. Okay, those are called as the use cases. We are going to work on couple of use cases on the city data frame and the prescribed data frame. Okay, and those use cases are, so calculate the number of jeeps per city, and calculate the number of distinct prescribers assigned to each city, and calculate total txc count for each city. Okay, these two transformation 83 and 84 can be done in a single line. Okay, so we are going to combine those things. And last one is do not report a city if no prescriber is assigned to it. Okay, so after doing the time, why we had to do the transformation means we have to send to the data analyst team, right? So they don't, they will discuss about the business insights. Okay, they won't do the disjoints, the group by conditions and all, right? Everything we had to clean it, and we had to process it, and we had to send the data to the analyst team so that they can think about at a business insight level. Okay, we are going to think how we can fill these two values. Previously we dropped, now we are going to fill the values in the txc underscore count with the average value. Okay, that can be done by using, let's open any file you want. Yeah, it is in a test file itself. So for that one we are utilizing the inbuilt method called as mean. Okay, let's do that one. Df prescribe city dot select dot mean of column, mention the column name txc underscore cnt, and if you put the dot show, if you put dot show, what happened means the mean average txc would become the data frame. We want a value, not a data frame. Okay, we want a value inside the data frame. For that one, I am converting this one to the RDD. By putting the color, you can convert it to the RDD. RDD is nothing but it's just like a list, right? So when you run this, yes, you got a value called 51.57. That is the average value, and we have to take that value. So it is in a list, and we had to eliminate this list. Okay, just wait a moment. Okay, sorry. And we had to take the value out of the list. So mention 0. Now the list has been, oh, what we can say. I'm not getting that word exactly. Now the list has been removed. Okay, let's print it out. Yeah, you got row average txt 51.57, and we want to collect that value. So again, pause value 0. Why? Because there is only one value. If there is any another value, we are going to pause that index 1 or 2 according to the value. Okay. If you run this file again, yeah, you got 51.57. That is the average value. With this value, we are going to fill the whatever the null value is present in the tx underscore count. Okay. So let's go to data processing. Okay. This is what I did. Okay. I used the fill NA concept. Fill the null values with the value mean txt underscore. Okay. This is the value and this is the column name. Tx underscore is the column name. Fill NA value and the column name. Right. And then I want to make my code bit reusable. On that occasion, previously we have written some code for checking the null values, right? Before dropping or before filling. After dropping and after filling, we have to again recheck it out. So in that case, it's better if you define a function and we are going to use that function directly in the driver file instead of in the data processing file. Okay, it makes a good sense. So for that, go to validate.py file. Let's define a function with check for nulls, pass the parameter data frame and a data frame name. Okay, data frame name, you have to pass it in a string. Okay, and write some loggers checking for null values, etc. etc. And return the same code. Okay, whatever we written in previously. Okay, instead of df prescribed in cell, I am going to pass only df. Then returning the check null data frame. So let's go to driver and call it here. Check for null values. In the df parameter, you have to pass the data frame for whatever data frame you want to check it out, and the data frame name in a string. Okay, so it makes some sense, right? Now we are going to look at the data transformations. Okay, first thing is we're checking for the number of zips per city. So this is the city data frame, and we have the zips column. So one state or one city can have the number of zip code, right? So they are asking that count. Suppose New York is there. For New York, how many zip counts are there? Similarly, for Hyderabad is there. Hyderabad, how many zip codes? Okay, Vizag, Chennai, Bangalore, like that. So we have the zips column, and we have to write an user-defined function like calculate the length of the zip, and you will get the count. Okay, we are going to define a user-defined function. Okay, converting the zip column into the list. So when it converted into the list, then when you use the length function, you will get the length of the elements present in the list. Let us say 6 or 60, so that you can say for the New York you have the 50 count. I mean 50, 20 zip counts. For Hyderabad you have that 15 zip counts, like that, right? So to convert any string to the list, we had to use the split function. Okay, and you had to pass the parameter, right? This will be like this. Say zips dot split. Here we have to pass the separator. If you observe these columns, you did not encounter any kind of comma separator or tab separator. It is separated by the space. So this is the code to convert the string into the list. Okay. So we are going to use the UDFs. Okay. And we are going to define the user defined function in a separate separate file called udfs.py file. Okay. And we had to mention the return type out of that. UDFs are nothing but functions what we defined so far and so good. But one thing is differ with the Python and Pyspark is in Pyspark we have to mention the return type of the UDF. Okay. In Python, in normal functions we did not mention the return types. Of course, we return the variable, not the type, right? Next thing is what calculate the number of distinct prescribers. Number of distinct prescribers are nothing but, so one city, let us say prescribers are nothing but, for you can assume like what can we say, like let us take any kind of Apollo or any pharmacy type, right? In a city, they can you can see the number of branches are available for Apollo. Okay, and each branch have the different IDs involved. So let us take that example. Okay, here the prescribed ID 206000252, right? This is the somewhat the ID. Okay, and they want the unique values out of them count. So previously we observed 13 lakhs records are presented in the CSV file. Out of 13 lakhs record, we want to get the count of the prescribed IDs, distinct prescribed IDs, means distinct dealers. Okay. Also, we can combine the next transaction, I mean next transformation use case, that is nothing but also he calculate the total TXT count for the distinct prescriber ID. You can observe 252 repeated here. Okay, and also TXT counts are every time it is differ according to the drug name. Okay, according to drug name is nothing but a tablet name. You can use it as like what you understand, right? So like that, we are going to group the prescribed ID and we are going to sum the TXT count. Okay. Sorry, not the prescribed ID. Okay. We are going to group the state and city. Prescribed state and city. So that you can get a n number of like, so if you group by city, what will happen means you will get the total number of branches presented in the Apollo, in a Hyderabad Apollo. Let's say, so if you group by Hyderabad, let us say you may have the thousand Apollo branches are there. If you group by Bangalore, you will get 1500 around. Chennai, similarly like that. Okay. If you group by city and state, you will get the count of the Apollo presented there. Similarly, we are going to group by state and city. Okay. And we are going to get the unique queue. Unique key is nothing but distinct prescriber count. So let's go to UDFs. Okay, this is the file I created. UDFs. Import the necessary types. Like as I mentioned, the major difference between the Pyspark user-defined function and Python user-defined function is in Pyspark you have to mention the return type like this. Okay, so we are going to get the count of the zip code, right? Count of the zip code is nothing but a count is nothing but an integer type. So I am mentioning that one. Return type is equal to integer. Okay. If you don't mention any return type, then it will automatically consider it as a string type. Okay. So I define a function column split count and the column as a parameter, and then I am saying return length of the column dot split by the space. Okay, like this. I have shown it, right? Zips dot split, and then I'm going to define another file with the data transformation dot py. There I am going to define another function. Okay, and I am going to make use of this UDF function there. Okay, and here I am going to write all the transformations and import the necessary things. From the UDFs, we want to import this function, right? And this is what I did here. Okay, and go to loggers. Okay, and you observed in a previous video, like you created a data processing file and you had to associate the custom logger for data processing file. Okay, for that one, similarly, we did it. Okay, go to loggers case, mention the file name, data underscore transformation, and let's define a custom logger here. Logger data transformation. I kept a warning level. Okay, handlers of file handler, call name data transformation, and let's define a function called data report and pass the two parameters df1 and df2. Df1 is nothing but df city cell, df2 is nothing but df prescribed cell. So why? Because as you can see, the transformation query, I mean, the first requirement is all about the city data frame, and the second one is all about the prescribed data frame. Okay, so I am defining the function in such a way that the two transformations can be handled by the one function itself. Okay, and I keeping everything in a try and exception block. Let's say log is of warning, passing the data frame method, and calculating the total zip counts in a format dfct cell. Okay, so this is the function you have to call it out. Dfct cell, I mean dot with column. We are going to add additional column zip counts. Okay, column and split count is this is the function we define in the UDF. Okay, and then this UDF has to associate with the column. That is nothing but dfct sales dot zips column. Nothing but we define a UDF and we are going to use that UDF to the associate column. Okay, or relative column itself. The next one is calculating the distinct prescribers. Like I previously said, we are going to group by city and state, and we are going to get the distinct prescriber ID. Okay, as well as we are going to get the sum of DXC count. That's what we are going to do now. Let us say DFC group is equal to DF prescribed cell dot group by DF prescribed dot, I mean, group by we have to state, right? Either you can do with the city. Okay, one is fine. DF prescribed city dot DFC city. So that by grouping the city and state, you will get it out the total count of the Apollos. Okay, and all. Let us say why, because state and city means, let us take the Andhra Pradesh state. Okay, we have so many states. I mean, so many cities like Vizag, Vijayawada, Anantapur, and all. Okay, and you will get it like AP, Vizag, Apollo counts, so and so, and again AP, Vijayawada Apollo count like that. AP Anantapur, AP Kadapa Apollo count like that. Okay. Next. Next, use the AGG as an aggregate function. Okay. Now, what is the condition? Get the distinct count of the prescriber ID. Okay. For that one, we are going to make utilize of the count distinct function. Okay. Directly, we'll get the distinct prescriber ID count. Okay. What's the column name? What was the column name? Prescribed ID. Okay. Dot alias. Let's rename it as PSC counts. Okay. Next one, sum. Okay. Sum of TXC underscore CNT. Okay. And remit as alias TXC counts. Okay. That's good. And the next thing is what loggers dot warning. Do not report a city if no prescriber is assigned to it. So what it is saying, do not report a city. Do not report a city if the no prescribers are assigned. Okay. Now what function we have to do means we have to think it about. Let's see the two data frames first. This is the prescribed data frame. We had the prescribed ID and prescribed city. Okay. And also we had the city data frame and with the city in New York, Los Angeles and all that. So with these two data frames, right? With these two data frames, if you join those two data frames by the city and state, and you will get the distinct prescribers who are not associated with the who are not assigned to the particular city. Why we had to join two data frames is nothing but here they will deal the details about the prescribed city. Okay, let us say city, take any name like you can take the example of Hyderabad. Okay, so you mention you have the details of Apollo presented in Hyderabad, that's fine. And you may have the another city, let's say any city, name it out yourself. Let us say city XYZ. Okay, city XYZ. In the XYZ city, there is no Apollo, but the XYZ city details we have it. Okay, and now when you join these two data frames, you will get it out. The city XYZ does not have consists of the Apollo pharmacy branch. Okay, and also we had another city WZ whatever. Okay, and there in for the WZ also there is no Apollo branch presented. When you join these two data frames, you will get it out the cities which are having the Apollo pharmacy and the cities which don't have the Apollo pharmacy. That is the main intention we have to join to these two data frames. Okay, we cannot say exactly the cities whatever mentioned in the city data frame will have the same number of cities presented in the prescribed data frame. Okay, so let's join df city cell and df trc. Okay, city join, and we are going to use df city split. Okay, join with df prescribed group. Okay, why? Because it make our process very simple. Why? Because we already group by city and state. Okay, like, and now we had to join, right? We had to join means we had to find it out the common columns. While we are joining, we have to find out the columns. Okay, so I'm going to join with the prescribed city and a city, whichever presented in a city data frame. Okay, I will show it there with the prescribed city and the city. That is one join condition. Okay, and a state name and a prescribed state. This is the another join condition. And I am going to use the inner join kind. Okay, inner join will act like a, it will join whenever the conditions are matched. Okay, it will eliminate the unmatched conditions, right? So let us say dfct cell dot state id equals to df prescribed group dot prescribed state. Okay, and dfct cell dot city equals to df prescribed group dot trace city. Okay, comma, and I mentioned a condition like inner. Why inner means it will combine the common things and it will eliminate the unmatched things. Okay, it will it will print the output with the matched things and it won't print the unmatched things. Okay, and the next thing, after joining, I'm going to select the required columns only. Okay, df final equal to df city select. I'm selecting the only few columns, nothing but the city, comma, state name, comma, county name, comma, population, comma, zip counts, comma, and a distinct prescriber count, right? That is nothing but we used it here. Copy that one. Okay, that's cool. Let's return df final. Okay. Now go to the driver file. Go to driver. Let's write a logger login.info. Data transformation for execute. Okay. Now let's import this one. Okay. From data transformation, import all the functions what you defined there. Okay. Let's say report underscore one. What was the function we defined? Data report one, right? Data report one. So pass the df cell, comma, df login.info displaying display So in our previous video, we defined, right, display function. Okay, nothing but a show, right? Now let's define the driver. I mean, now run the driver. Yeah, our application got executed. Okay, let's see the output. Okay, city, state, county name, population, and zip codes. Let's say the city, San Leos have the 5. Okay, Lamore has 1. Okay, and the prescriber count is 11. I mean, distinct prescribers. I mean, distinct dealers. Okay, and 194 for some other city. Snow Hill has the 5 distinct prescriber count and 1 zip code. Okay, right. So our program application got successfully executed, and you can make some more a bit readable. Nothing but, and we have the prescriber counts are there, right? So for the prescriber count, you can mention some order, either ascending order or descending order. Default it is a ascending order, like 1 2 3 4 5. And when you mention the order descending order, you will get the top higher number of prescriber count as starting record, and the lower number of prescriber count as the below record. Okay, you can, those are the add-ons. Okay, as you wish. And in the next video, we are going to make one more part of this transformation, and we are going to take couple of transformations, and we are going to process those things. Okay, still there is part 4 is coming. Once after transformations done successfully, and we will going to look how we can how we can put this cleaned data frame. Okay, data frame into the AWS S3. Okay, or Azure blob, whatever. Okay, that's it. That's it from the video. Okay, thanks for watching.